Hello guys and girls, welcome to a new clip in the C# for Beginners playlist. I was mentioning in the last lesson that we can implement OOP with the help of two constructs, classes and structures. But I was also mentioning records as something aimed at storing data, and that's what we'll discuss today. As we will learn later, there are numerous times when we will need to create custom data types that do nothing more than hold information. Something like this. And if you look closely at the student class, it's what we call a dump object, meaning it has no methods, no functionality at all. It only contains properties that store data. And we typically refer to this kind of object as a DTO, data transfer object, because its purpose is to hold data and transfer it between various parts of the program. So for example, if you have a method, instead of taking an int age, string name, and so on as separate parameters, we can declare a class with these properties and take a class like that as the parameter for that method. And usually DTOs are used, for example, with databases where you have, I don't know, a table called invoices where you have 1000 rows, where each row can sit in an instance of an invoice class. So in that case, the properties of that class would be mapped one-on-one with the columns in each row in that table. This works, but it has some downsides, like for example, the verbosity. We have a lot of properties and each property has getters and setters and so on. And this is made worse, for example, if we want immutability, where we can initialize them, we can set them initially, but they cannot be modified afterwards, in which case we would need to either mark them as required and init, or we need to declare a parameter with mandatory constructors and then manually assign their values to the read-only properties, initializing them and so on. Now let's do the same thing using a record. And you have to agree the syntax is much more concise and the boilerplate code is minimal. And we use them the same way we would with a class that has a constructor with mandatory parameters like this. Notice that these are not parameters like in the same sense of parameters of a method. So we don't write them as variables. They are translated to properties. So we capitalize them using Pascal case just like we do for normal properties. You should also know that there are other differences between classes and records. One of them being the fact that records are by default immutable. So this would not work. Another difference is that records implement equality by default. To understand what I'm talking about, let's take an example. So I created two instances of records, but I assigned the same values to their properties, and then I compare them. And I do the same thing for the class example too, where I create another instance, but I assign the same values to its properties, and then I compare the two instances. And of the two, only the records equality will pass. That's again because records implement equality by default, meaning the values of their properties are compared, and if they are equal, the equality passes. But in the case of classes, what is actually compared are the heap cells, heap addresses that are stored on the stack cells, and if they are different, the equality fails. And of course, if we declare two instances, that means two separate heap regions, which means two different addresses, and of course they cannot be equal. That's why the equality fails. If you don't know what I'm talking about, go watch my clip about the stack versus heap memory. Since I just explained that once we create an instance of a record, we cannot modify the value of its properties, if we want to update it, the only way to do so is using the with keyword like this. And in this case, we don't modify the initial value, we use it to clone it and update some properties and then reassign the entire object to the original variable. So we never modify the initial instance, we just create a clone of it with updated values and we reassign the entire object. The original one is never modified. And if we want to just clone an object and not modify anything inside it, we do it with this. By default, a record is treated like a class, meaning a reference stored on the heap. But since C#10, we can also declare records as structures, which are value types stored on the stack memory. If you again don't know what I'm talking about, go watch the clip. We can also explicitly declare the properties of a record like this. But be careful, in this case the immutability is no longer implemented because I manually specified a setter. The only difference remaining would be the implicit equality check. You should also know that immutability is only applied on simple primitive data structures. So for example, if the record has a parameter which is a class type, the properties of that class will not be also immutable. So for example, in this case, we have a class battery, so class is allowed to change the properties because we have a get set, and we have a phone, which is a record, so immutability by default, and one of the properties of that record is of this class type. So when we try to modify the model, one of the properties, a primitive property of the record, we get an error because again we cannot modify them after we create it. We can also not modify the battery property because again this is a direct property of the record, but we can change a property of the property inside the record because it's a property inside the class and that's perfectly modifiable. So be careful about that. Records can be marked as abstract, they support inheritance, they can be declared as sealed, so to prevent further inheritance. The boxing and unboxing rules still apply to them and a few other concepts that we haven't learned in this playlist yet. So for the purpose of this lesson's completion, I'll mention them, but don't stress about it. So the only remaining question is, when should you use a record? According to Microsoft, their purpose is intended as storing data, but I said pretty much the same thing about structures in the previous lesson. The only difference is that structures have that by value semantic which I explained. So when you have a unidirectional flow of data from some data source like a database, and you need to store the data in memory in something to deliver it to some various parts of the program that needs to process it, and storing it implies not modifying it until it gets there, well, for that purpose, records are ideal because they are immutable by default, and that's why you should use them in that case. That was it for today, and if you enjoyed this lesson, don't forget to like and subscribe, it really helps this channel to grow. For now, thank you for your time and for watching, and I'll see you in the next tech frame.